At the end of this video, you should be able to explain what isotopes are, define atomic number and mass number, and describe how they apply to isotopes, and given the identity of a nuclide, determine its number of protons, neutrons, and electrons. Chapter 3, Section 3, Counting Atoms. Consider neon in E, the gas used in many illuminated signs. Neon is a minor component of the atmosphere. In fact, dry air contains only about 0.002% neon. And yet, there are about 5 times 10 to the 17th power atoms of neon present in each breath you inhale. In most experiments, atoms are much too small to be measured individually. Chemists can analyze atoms quantitatively, however, by knowing fundamental properties of the atoms of each element. In this section, you'll be introduced to some of the basic properties of atoms. You will then discover how to use this information to count the number of atoms of an element in a sample with a known mass. You will also become familiar with the mole, a special unit used by chemists to express the amount of particles such as atoms or molecules. Atomic number. All atoms are composed of the same basic particles. Yet all atoms are not the same. Atoms of different elements have different numbers of protons. Atoms of the same element all have the same number of protons. The atomic number, Z, of an element is the number of protons in the nucleus of each atom of that element. Consider the element shown on the screen now with the basic information from the periodic table, which can also be found inside the back cover of your textbook. An element's atomic number is indicated above its symbol. Notice that the elements are placed in order of increasing atomic number. At the top left of the table is hydrogen, H, which has an atomic number of 1. Atoms of the element hydrogen have 1 proton in the nucleus. Next in order is helium, He, which has 2 protons in each nucleus. Lithium, Li, has 3 protons. Beryllium, Be, has 4 protons, and so on. The atomic number identifies an element. If you want to know which element has atomic number 47, for example, look at the periodic table. You can see that it is silver, Ag. All silver atoms contain 47 protons in their nuclei. Because atoms are neutral, we know from the atomic number that all silver atoms must also contain 47 electrons. Isotopes. The simplest atoms are those of hydrogen. All hydrogen atoms contain only 1 proton. However, like many naturally occurring elements, hydrogen atoms can contain different numbers of neutrons. 3 types of hydrogen atoms are known. The most common type of hydrogen is sometimes called protium. It accounts for 99.985% of the hydrogen atoms found on Earth. The nucleus of a protium atom consists of 1 proton only, and it has 1 electron moving around it. There are 2 other known forms of hydrogen. One is called deuterium. This accounts for 0.015% of Earth's hydrogen atoms. Each deuterium atom has a nucleus containing 1 proton and 1 neutron. The third form of hydrogen is known as tritium, which is radioactive. It exists in very small amounts in nature, but it can be prepared artificially. Each tritium atom contains 1 proton, 2 neutrons, and 1 electron. Protium, deuterium, and tritium are isotopes of hydrogen. Isotopes are atoms of the same element that have different masses. The isotopes of a particular element all have the same number of protons and electrons, but different numbers of neutrons. In all 3 isotopes of hydrogen, the positive charge of the single proton is balanced by the negative charge of the electron. Most of the elements consist of mixtures of isotopes. Tin, for example, has 10 stable isotopes, the most of any element. Mass number. Identifying an isotope requires knowing both the name or atomic number of the element and the mass of the isotope. The mass number is the total number of protons and neutrons in the nucleus of an isotope. The three isotopes of hydrogen described earlier have mass numbers of 1, 2, and 3, as shown on table 3-2 on page 76 of your text or on the screen now. Consider the same element shown on the screen 2 slides previous. The average atomic mass is strikingly close to 16. Knowing the atomic number 8 refers to the number of protons found in the nucleus, it can be determined that there are 8 neutrons in the nucleus as well. Designating isotopes. The isotopes of hydrogen are unusual in that they have distinct names. Isotopes are usually identified by specifying their mass number. There are 2 methods for specifying isotopes. In the first method, the mass number is written with a hyphen after the name of the element. Tritium, for example, is written as hydrogen-3. We will refer to this method as hyphen notation. The uranium isotope used for fuel for nuclear power plants has a mass number of 235 and is therefore known as uranium-235. The second method shows the composition of a nucleus as the isotope's nuclear symbol. For example, uranium-235 is shown on the screen now as a U with 235 superscripted to the left and 92 subscripted to the left. The superscript indicates the mass number and the subscript indicates the atomic number. The number of neutrons is found by subtracting the atomic number from the mass number. Thus, a uranium-235 nucleus contains 92 protons and 143 neutrons. Table 3-3 on page 77 of your text, or on the screen now, gives the names, symbols, and compositions of the isotopes of hydrogen and helium. Nuclide is a general term for any isotope of any element. We could say that table 3-3 lists the compositions of 5 different nuclides.
Notice that carbon-12 and carbon-14 have a different number of neutrons. We call these different carbon atoms isotopes.
At this point, you should be able to explain what isotopes are, define atomic number and mass number and describe how they apply to isotopes, and given the identity of a nuclide, determine its number of protons, neutrons, and electrons.